So, well, GSMTAP was obviously a great idea, and we used it extensively over the years. It's obviously a great debugging tool. However, it's been kind of designed for GSM, and now it supports things like WiMAX, SimTrace, GMR.
Sim is at GSM.
Okay, it's been designed for you, and so a lot of the fields are irrelevant for those protocols, which is not too annoying. But what's more annoying is that there are some fields that we would like to see there, and we have no way to put the information. So the idea of a new version of GSMTAP has been great before, because it's an obvious idea when you have limitations to just evolve the protocol. But it hasn't happened so far, and I think it's time that we take a very serious look at it. So I just tried to draft a few requirements of what we should definitely think about, and this is really only a rough draft of things. I have no formal specification.
No ASN1?
Yeah.
No CSN1 here.
So the first thing it should be is extensible, because we're definitely gonna work on other projects than the one we have right now, obviously, and we don't want to have to rewrite the GSMTAPv3 next year. So we definitely need to have some modularity in there. It should be specified in at least one reference document. Currently, the only GSMTAP spec is essentially the other 5, and some of the field, different programs use different encoding for different fields. Some of them are just not specified at all. I mean, it says, okay, you can put raw burst data in there, but it doesn't specify a format, it doesn't specify a bit order, it doesn't specify anything. And so different programs that use different approach depending on what they needed. So yeah. Yeah, I think it'd be nice if it was an RFC, but this actually looks it's pretty complicated and time consuming, so that might not happen.
And actually, for FC to become a standard, it requires at least 2 implementations, independent of each other.
Okay.
Well, but I think Wireshark will not link with OsmoCore, so there are 2 that.
Perfect. It should definitely have an easy-to-use API, because currently creating and passing a GSMTAP packet is very easy, and if we want people to use that version instead of the previous one, or to adapt the program, it should be easy to use. So that will need to be reflected somehow on the protocol level, so that you can not have too many details to care about. And then ideally it should be fairly easy to port both application to the new protocol. For example, if we relink application with a newer version of the OsmoCore, it could be transparent that it no sense GSMTAPv4. For sending it's easy, for receiving it's a little harder obviously, because previous application just essentially mapped the buffer to a strict yeah.
We don't have many receiving applications.
But we don't have many receiving applications except for Wireshark, which is easy to take care of. So yeah.
Now that they merge our patches.
Exactly, now that they merge patch very quickly, it should be fairly seamless to the user.
One of the Wireshark developers even has a SimTrace now.
So this is basically something that I came up with. Very rough idea. Essentially, you would have a fixed error that is very minimal. It's detailed later, but essentially just contains the version of the protocol so that we can differentiate it from the previous version, and some basic type that will tell you how to interpret the rest. A few common requirements to like all the previous versions of GSMTAP as well is try to keep things aligned for easy so that you can just map it in memory. If it's aligned at the start, it will be aligned. You don't have to clear too much. Specify the byte order, obviously, and yeah, all package should, everything must fit in a single UDP packet. Currently, it's not an issue, but maybe for future. I mean, I don't know all the protocols that exist, obviously, but maybe at some point we will have data payload that are too big, and I think we could possibly take care of that just using IP fragments. But currently, it's not much of an issue, and I just think we can make the assumption that one packet is one payload, and that's it.
Want to make because you want it real time?
Sorry, I just don't want to deal with fragments, you know, at the application layer. That's mostly it. Because since I want an easy to use API, I don't want the user to have to care about lost fragments and, you know, things like that. That becomes very complicated to deal with for something that's mostly used on, you know, the LO interface with a 65,000 MTU. You know. So the common part were pretty much compatible with GSMTAPv3, that is a version that is just fixed. The header length that allows to skip directly to the data payload. The type, that's exactly the same type that is in GSMTAPv2. The only difference is that the third byte used to be the time slot. I don't know where it was there, whatever. And just put the subtype in there, which would be interpreted obviously according to the type, yeah. And another thing I thought about is that the type could be what I call the authority split point, that is currently mostly around looks at maintaining a coherent version of the specification, but for some protocol like WiMAX or things that you know, not everyone knows about, and maybe another person would be more appropriate to say, okay, if the type is WiMAX, then, you know, that person is responsible for the meaning of the fields and things like that, and have a list that says, okay, this type is managed by this person, and you should contact him if you want to make modification that will become authoritative in Wireshark and specification. The variable header.
Yes,
so the variable header essentially is TLV fields. So just have 8 bits of a tag, 8 bits of a length, and then the actual value, or whatever length is needed. The advantages of that is that if an application doesn't know about a particular tag, it can just ignore it and skip ahead with the length. Some tags, depending on the type, for example, let's take something that a lot of people will know, GSMUM. For example, you could require that the frame number is a mandatory tag, because it's applicable to all the packets, and if you specify it as mandatory, that means that the receiving application can expect it to be there and abort if not. You know, it should be there. Some other block could be optional. For example, if you have like the receive levels on the antenna, you know, that's something, okay, Wireshark can display it because it's nice, but an application that would use a GSMTAP stream, you know, you can do without it. It's really purely informational, or a command field, things like that. You could segment the address space, you know, between some tags that are agnostic, like a text command that just says, okay, this packet has been captured, you know, at this location, or GPS coordinates of the capture, or you know, whatever information you want to put out there, and some should be protocol dependent to save the address space, because there is only 256 value. You can't just waste them. And things like that. Also, I think the blocks should not be a single value, like because this will waste a lot of space, and some values are always going to be grouped together. Typically, if you say logical channel information for GSM, it's always going to contain the time slot, the type of channel, the subslot. Okay, this might be a bad idea because this all fits in 8 bits, but what I mean to say is that they are really more like header blocks that contain several values and not necessarily a single value. All of that has to be defined, of course.
Okay, some comments on that. The first thing is if the length is encoded in, maybe it's worth closing the window now, maybe. I'm not sure if this one is fixed okay. Regarding the length, if you specify it in 32-bit words, then you also have to specify padding somewhere, because your values may not be always 32-bit. They may be variable lengths, and they may not always have a divisible by 4 length. So there would have to be 2 bits for specify how much padding at the end at some point. You could squeeze those 2 bits in somewhere else, but that's just as a comment. Also the question would be if 256 times by 4, so a 1 kilobyte maximum payload inside the TLV is really sufficient. So if there's a field longer than 1024 bytes.
And also the access to the payload will be unaligned. Every access to the payload, if the tag is 1 byte, the length, when every time that you're going to access the payload, well, it's not serious, but it won't be aligned.
Yes, I mean, for the I'm trying to take the 3 points. So yeah, indeed, for the padding, I didn't think about that. I said I just plotted something so you would have a base starting point. So yes, indeed, it could be byte, but then you fall into the limit that you had maximum 256-bit length. On the other hand, this was mostly targeted for header blocks, and those are fairly short. They're not meant to represent the actual data payload. So like in GSMTAPv3, you have an actual data payload that you're supposed to know what's in there depending on the information that's in the headers. So you wouldn't find the L2 data on there.
So you should basically have a TLV for the payload length.
But the payload length, you know it because you have the length of the UDP packet. You kind of know what length your UDP packet is.
I mean, if you have a multi-frame packet,
Yeah, exactly why I didn't want to deal with segmentation. I leave that to the IP layer, so to give me a single UDP packet. That was the idea.
No, I mean, I think, okay, so if you look at GSM, which I guess most people understand here, we have things like the L3 information element in a number of protocols, where even the actual upper layer payload is encapsulated in a TLV and then represented in something similar to this. And you basically said you didn't want to do that, you just want all the remaining part which is not TLV encoded. But then how do you know where the end of the TLVs is? Is there in the static header in the beginning, will there be a pointer at the end?
You have the total length of the payload in the fixed header, like in GSMTAPv3.
But how do you, okay, so then you subtract it from the end of the packet to reach that. Another option would be there are some protocols that have an end of options TLV. Yeah. So basically you could have that.
Yeah, or we could have a fixed header, or in fixed header we could have a place for the header length.
Yeah, this is here.
There is a place for the total header length in the fixed header.
Yeah, if you have header length, we have UDP. Yeah, you mean.
Because GSMTAPv3 add that to directly skip to the payload, so I kept this because it seemed like a...
But why do you have only 8 bits per tag and per length? Because I think you want to be 32 bits aligned, but now you break alignment. Because
but there is no need. If you would have a tag that stores 2 integers,
there is no need to squeeze the first 16 bits just after the length and then have some unaligned access. You can just waste it. You can define how your TLVs look like. And actually I really like this idea that a short information that only has 8 bits or whatever just fits in one single 32-bit value. I think this is...
When I looked at what information to store for like logical model information, stuff like that, most could actually be squeezed in only 16 bits, either as two 8-bit values or as a single 16-bit values, or the other ones were like 32 bits. But then you can just say, okay, the header is tag value 2 padding bytes, and then the 32-bit value.
But okay.
And then you have it aligned.
Okay, maybe just an idea. So what if we have the most significant bit of a tag, or of a tag, for example, representing length of the tag and len. So if it's 0, we have 8 and 8 bits, and then 2 bytes for the data. If it's a 1, then you have 16 bits for a tag, 16 bits for a length, and then you have 32 bytes aligned data.
This is more like Q931 does it for ISDN. It has short TV fields and longer TV fields, and it has a bit to...
I have no idea about ISDN to say.
GSM also has it. There are some, not GSM layer 3, but there are some protocols, I don't remember which one was it, but there's one at least where you can have either TLV or in our libosmo call notation a TL16B. So the length of the but what they do is, I think the length of the length field is encoded in the length field itself.
But I think it's actually a pretty good idea. You could have like encode the length as, okay, if the length field is like FF, then the 2 following 16, or if the MSB of the length field is like 1, then you have a 24 bits length field.
Well, there's another way. If the first bits of the length is a 1, then the remaining 7 bits say how much length the length field will be. How long?
No. There's a standard way of doing this that you see in the ISDN and SS7 world, and it's used an extension bit. So you designate one bit, usually the least significant bit of the length field, as the extension bit. And any, I forget what, if the extension bit is 1 in the last octet of the length field.
Okay, yes.
So you can have as many length fields as you want until you hit the one where the extension bit is 1, and then you know you reached the end of the length field.
Also a bit like BER, I think.
Yeah, it's it, yeah.
Yeah, and exactly that's how
You can do the same thing with the
engineering
type field
starts.
too, if you want to plot it.
It was simple at the beginning.
But then it's sufficient if we say, we can specify it like Sylvain said, but we change the protocol dependent and reserved ranges. And then we have anything that starts with the MSB1 in the tag. Well, okay, no, it's the length field. But anyway, I think we can just leave it. If we have some reserved bits, we can just start with this like now, and if somebody runs into the need of having longer length fields or something, then we still have the reserved bit that we can start.
No, but the idea was not to have a length, more length for more space for the length, but to have 32 bits aligned data. So
yeah, but the thing is I don't see that as a problem, because if you need 32 bits, the thing is you don't always need 32 bits aligned data. You need 32 bits aligned data if you need a 32-bit field. Aligning a byte field on 32-bit boundary doesn't make sense. So if you have a 32-bit field to store, like the frame number, you can say, okay, well then my header content is actually 2 padding bytes, and then
the other way to deal with the padding would be to say the length field always represents the real length of the payload, but the next tag will be 32-bit aligned.
what?
So basically, between the end of the data field of a previous field and the next tag, you will always have as much padding as minimally required to reach the next 32 bits.
Yeah.
Yeah, that's it, that's it. Yeah, yeah.
Exactly.
So you skip actually length plus 3 times divided by 4
Yeah.
32-bit words.
Yeah. That way we could avoid that.
I can pass you some macros that we use. Actually, we could use NetLink or the TLV facilities that NetLink provides in the kernel to define these TLVs, and they provide also already the function to add the padding and all that stuff.
And then you start having rest octets, you know.
We start introducing rest octet in GSMTAPv3.
And this is a stuff that this is to transport data that is traveling in user space. So I think there is no point in trying to pack all the information. We've got plenty of memory, so we can stick to the 32 bits alignment. I think.
Did you take notes of?
Some of it, but it's also recorded, right?
Ah, yeah, okay, yeah.
So-
Because I'm not gonna remember.
So and just a question, one question I missed. How have you defined a block? Because I mean, is it a TLV in a TLV, a hierarchical structure?
No,
or
no.
it's,
It's a flat structure.
So
So
what
you-
is a block? I mean,
Well, a block is anything that you define for the given protocol. For GSM, as I said, you could have a logical channel information block that contains the channel number,
so I mean,
the time slot,
yeah, I get that, but is there any like physical representation of a block, like a star block TLV and block TLV, or it's just like a virtual,
No,
like
with-
logical
I
separation?
think with block he means the payload of any of the TLV objects.
Yes, yeah.
Yeah. So block here means the payload followed after tag and length.
So
So it's a value basically.
Okay.
It's
Okay.
the V of the
Yeah, the V.
Okay. So it's basically a structure
Yes.
being a payload.
Exactly, yeah.
Okay, got it. Because I was supposing that block is a several TLVs.
Oh, no, yeah, sorry, it's not, I didn't use a very consistent naming scheme, but yeah, essentially you define a strip that contains the V,
Okay.
and then it's defined so that it
Yeah,
will fit
got it.
properly in there. What the data payload is, we can switch slide.
Do you think that 64 different protocol independent tags would be enough forever?
Well, forever,
There will be a special one
Then
that
we
says
have to-
payload is XML and
No. Then we will define a new virtual protocol that is also protocol independent.
yeah, something like that. The thing is, it's never going to be forever. It's long enough.
Well, if you wanted to have it forever, then you really have to use BER kind of rules where you can grow the tag length, you can grow the length, you can grow the payload length, you can grow everything. And you can have nested TLVs, but then, yeah.
The thing is, in the end, there is not that much that's shared between all. When I already can't find much that's common between like SIM and WiMAX. What's common? The time at which you received it. That's
and if you have a pkip file, it's already there. So
the text comment. I don't think there's that. They're not valued. They're really
By the way,
low
I
values.
have a funny comment to make. The TCP dump guys, I mean, there's some people that maintain the list of data link types in the PCAP header. So PCAP has a data link type, and I mean, for GSMTAP, we always have IP and then IP and UDP and GSMTAP and so on. But originally, when I started GSMTAP 4 years ago, I sent a request to the TCP dump guys for assigning me a data link type. And it took a very long time. And now after 4 years, I get another email to that original inquiry. After 4 years, response just a couple of days ago. It's like, oh, did you ever use the data link type? So So
has one been assigned?
yeah, two actually. We have two because I assigned one for and one for APs at the time. So now we have two data link types in the PCAP header. So we could also have native GSM type without IP in between. I'm going to add that to Wireshark soon.
Yeah.
Felt like a message from the past.
It arrives as a fax.
So data payload is essentially the same term as GSMTAPv3. Whatever you need to encapsulate in the first place. If there is some special description of what format that payload is, for example, if you send a raw burst and you must specify if there are, soft bits, hard bits, however they're packed should be specified earlier in the variable headers. And then we do the data. Nothing to say. Here you can go to the next slide. So this is just a few examples of what the variable headers could be for GSM, like a stream identification. Because one problem we had with LAPD not so long ago is when you want to do the reassembly, you need to know which channel this corresponds to, which is not especially easy when you're on hopping, when you are actually monitoring multiple hopping channels at once. You essentially need the original information from the immediate assignment, which Wireshark doesn't have, and so it's something that the application could provide optionally to Wireshark. Is say, okay, all these packets belong to the same kind of conversation. The logical channel information, channel numbers, time slots, subslots, all these things. Timing information like the frame number, the time at which it has been received, that's real time. The frame numbers really. But these are really just examples, and for each protocol that we support, we have to, of course, run specification. Once we actually get to that, you can switch things. The API, I think that's.
I have one small comment to the last thing. Data type, I think this is something that shouldn't really be encoded there in these variable headers. Because this is just fundamentally changing the meaning of the payload. So it's not additional information.
Yes, but it doesn't exist for all.
Yeah.
For some, there is just no. For some payload, it doesn't make sense. That's kind of the problem I had. You know, for like L2 frame information, there is no question of what's there. For the APU of a SIM trace, there is no multiple format there.
I mean, I could
imagine and others, but
yeah, but I see that as more as a subtype of the because they're not different ways of encoding the same information. They are completely different channels of information.
So you could do that because you could send L3 in a packet mode or in unpacket mode where every bit is a byte. So there's definitely different representations.
Yeah,
I wouldn't want that.
Could do that. If
Yeah, I mean, but it's just an example. I mean,
but yeah, I see your point. But the thing is, currently, I've looked at the way GSMTAP is used now, and the only places where I saw that this would make sense, kind of format this information, is to transmit raw bursts, because there is really several formats to represent them, and applications that some use floats, some uses soft bits like on 1 byte, some uses packed soft bits where they pack 4 soft bits in one 16-bit word.
I think we should specify that if we allow too much freedom there, it will not be possible to represent them in a generic way.
I totally agree that we should specify each possible types and say, okay, this header is for the rovers, this header specifies the format type, and this value means that the data payload is in that format.
And then this TLV is
or
mandatory
do you mean really
rollers.
only allow one type of?
Yeah, I was more referring to to just allow one type, because if you specify all the possible types, then each and every receiver to fully be compatible would have to implement all the different formats. Otherwise, it then ends up incompatible. So I would rather say standardize more and thereby create more interoperability.
Okay.
And then you can go on the absolute other extreme, where I've seen it done where you specify the sample format with two numbers. One number tells you how many bits per sample, and the other number tells you how many samples per sampling group. So if you want to do in-phase and quadrature, or get multiple antennas, or,
Yeah, I think I'm more with forced performance. Yeah, I mean
I mean, if somebody wants to do it, then he can still do it that way, but we shouldn't encourage to come up with different formats.
no.
Yeah, if you really want if you want to use GSMTAP between applications, which is also one thing that I would like to do, it definitely makes sense to force the user to use something.
What I see for GSMTAP usage is that it's usually just a wrapper around what is already used in the application. I mean, we don't usually convert data exactly for GSMTAP. Usually just like put a blob we already have, put in a header and send it. So that's how we use it right now. So basically, it means that we should be able to add types pretty easily and just specify what's in there. So we don't have to have all types of everything, but it should be easy to specify new type, because if you change your application to have another binary format of data, you should be able just to add a new subtype and put in data.
Yes and no. I mean, I understand, yes, from the application developer point of view, of course, you prefer to always export the data in the native format you use internally. But in the specific case of samples, I think there is some gain to have from specifying in the GSMTAP spec what exact encoding the samples should have, or what exact format the samples should have. Because then you can have a receiver application or some whatever processing application that only has to implement one type of input format for samples and doesn't have to implement 16 different ones for 16 different sources of data.
Yeah, I mean, this is true, but right now, I mean, there is two thoughts here. First is that the sending application may be very resource constrained one. And the second is that right now I think Wireshark is the only receiving application we have. So it should not be that hard to have several implementations.
Yeah, that's something that I like to change, is that currently Wireshark is the only receiving application, but I see GSMTAP as a good format to exchange information between different programs. Like, for example, something that extract raw samples from burst and then converts them into the two messages.
So for this multi-RX, it would be a perfect.
Yeah, exactly. Things like that.
Yeah.
And for that, you need some kind of consistent format.
Even one of the things that I always had in mind and discussed with lots of people in the past is having a virtual layer 1 for OsmoBTS and for OsmoComm-BB, that you can actually have virtual instances of OsmoComm-BB, like 1,000 phones, that talk GSMTAP to OsmoBTS, which then talks ABIS over IP to OpenBSC, and you have a fully virtual setup, and you have thousands of phones, and you can simulate handover and all kinds of situations in there. And of course, GSMTAP is, even in the existing format, is a very good match for this kind of exchange. You just send all that to a multicast UDP group, and you have the RFKIN in the header, you have time slot, the frame number, everything. So you have a shared medium, but it's completely over IP for transporting it. And I think there will be more applications like this in the future.
I see the point, but still, my belief is that we should care more about sending application, because it's usually the sending application is more restricted in resources than receiving application. It's just like
Why is that? Because GSMTAP is, I mean, the sources of GSMTAP messenger, I don't see enough, especially
The receiving
resource-
application, the receiving applications, Wireshark.
Yeah, and Wireshark is a very, very CPU intensive and resource intensive process.
I'm just saying, every time you add another format, you're adding more complexity to Wireshark. So
Yes. Yeah, and not just to Wireshark, but to our other possible receivers. So, I mean, I totally agree with what you are saying. Let's say, well, whatever, you add a new GPRS coding scheme or something like that to your sender, to your GPRS implementation. Then of course you want to natively send that encoded blob like it is over GSMTAP into whatever is the receiving application. It's no argument here. So if there are native higher level data types from whatever communication system you implement, yes, they should just have an additional GSMTAP header with whatever number of variable fields and send it off. But if it's something more low level, like the samples or something like that, then it makes sense to specify the format. I think even if it imposes some additional computing power, because as I said, otherwise we have 16 different sending applications and 16 different receiving applications, and then all of the things need to be implemented, you know, dozens and dozens of times, or they are not compatible, and it's not nice. I don't like it.
okay, yeah.
I don't think the format is going to be, conversion is not going to be much of a problem, because it's not like if you're sending the converting between the raw bits and the L2 messages. Those are two completely different channels. It's more like converting between a byte value and a 16-bit integer value. You know, it's not
Yeah, so
that big of a
okay,
deal.
well, let me like make the last comment here to end this discussion. So I will just try to clarify what I mean. So like for example, if we run like OpenBTS on an embedded board and we want to dump raw bits, then we don't have a lot of processing power to make conversions on this embedded board, while Wireshark in this situation would run on a big computer, 4 cores, and could do any conversion. So that's the use case I care about. I don't think it's but I don't think it's really a big issue. So I'll probably we are discussing too much about.
Yeah, because I don't see, I mean, anything that you're dumping raw samples from has to have software radio functionality built into it. I don't see anybody putting software radio functionality in Wireshark anytime soon.
Yeah, well, okay.
So
And
I think the raw sample case is an edge case. It's really not.
And in any case, converting between like even floats or whatever into the format that we decide on is going to be like nothing compared to a single operation of the demodulation.
Okay.
And just the correlation of the training sequence is going to take orders of magnitude more of processing power than converting.
I don't even see wire. I don't even see this format as being an appropriate format for handling raw samples.
Okay.
It serves to, it's a protocol representational format. It's not a raw sample presentation format.
Yeah. Okay. So yeah.
But at least let's say okay, then demodulated soft bits probably is the
Even that's questionable. That's a ragged, because even then that's almost meaningless. If you're not going to build layer 1 for error correction into Wireshark.
Yeah, but the idea
Yeah,
is,
for Wireshark, yes, I'm thinking about other
Yeah.
communication between different blocks of applications. Typically, if you want to ship the data that you sniffed on the phone to an application that actually does something with those data, you need some way to convey it, and you're going to have typically the same kind of information. All the other information like RF and stuff is going to be common, so you want to use kind of GSMTAP. Some people have done those applications using GSMTAPv3, except different people have chosen different formats. And so,
He needs this protocol for his ASOS center, which will be installed in online from CPU behind the center. There's everything behind. satellites to via whatever tetra.
Move to the next slide.
Bundestag, of course.
Yeah, so that's just a very quick API where basically currently you have one single call to create a GSMTAP packet. Now you will have several where you create one variable header one at a time and just finally call the data. This is obviously an implementation that uses our standard MSHB structure. But the same kind of cores and general idea of the API is there.
Just one comment, you're passing in a message buffer but also a length value, which is sort of a bit strange, because either you would use the length that's already present in the message buffer structure, or you would also have to specify where to start from. So I think if we...
Yes. For the get, you mean?
No, for the add data, for example.
For the add data? Yeah.
Add data, the second one. You pass in a message and the length, but
Yeah.
the message buffer already contains a length value internally.
This would essentially call MSGB. The add data would essentially be MSGB put. It would add the size in the MSGB for that.
Okay.
And it returns you a pointer where you actually write what the value you want.
Okay, that way around. Okay, I thought it would be different. That message contains what you have, and you want to add that.
You construct your MSGB. But and get header here as the len, despite the fact that in theory you have it in the tag, just to make sure that that the data in there is valid and you're not trying to call.
Yeah, and by the way, could we get away from the name MSGB? Because it's not specific enough. Recently, Evan had a name collide between MSGB in OsmoCom and in some other library. So could we get it some like Osmo MSGB or I don't know.
Do you know how much work that is?
Huh?
Do you know how much work that is? Have you checked on Git Osmocom.org how many projects there are?
I mean, could we get it at least for the public header? It's okay to have it inside the library, but for the public header, like a type def, I don't know, whatever, but don't name it MSGB.
It's too late. I mean, there's probably, I don't know, 24 applications that use it in hundreds of source files that use it with that name, and changing all that will be...
but just for GSMTAP, at least for GSMTAP, so that's the least we could do. I mean, okay, don't touch Osmo core.
But you can if it conflicts in your application, and you can make yourself a wrapper header for your application that isolates the namespace. I think something like that has to be done with integration with the zip library, where you have like an intermediary, because you had a name conflict for, I don't remember which. For OSIP there was
something, I don't remember what it was.
And there is a way to work around it in your application. It's annoying, but
I mean, I don't mind renaming it. The problem is just that there's so much code that needs to be changed out there.
But type def helps usually.
And it creates all incompatibility.
Sorry?
Type def helps usually.
So you want to rename it in the library, and in the library have a type def to the old name? That doesn't make much sense.
What we care is a public API, because that's where you have...
Yes, but we have lots of applications that use that very same public API with the old name.
But then, then you could have if def use, if def compatibility type def. If def compatibility no type def. I mean, it's just the bad name. No.
What is the other library that is colliding with this, which is using the same namespace?
Well, I think even ORTP is using...
Yeah, ORTP it was. Right.
Yeah, but it's the same problem.
It's
been in some way, because we have the same conflict. The same conflict.
Yeah, but it was resolved. I don't even know how I solved it. It was not...
Yeah, we already resolved it, but I mean,
Yeah.
it's better not to have such conflicts.
We can complain to OpenRT.
Do you know how many applications they have?
Yeah, but there are not so many combined applications.
Yeah, I mean, it's not supposed to be a discussion right now. It just appeared in my mind when I saw this. Something to think about.
We may start if you want to do it, we may start a gradual migration, but it's not going to be quick. Just call it OMSGB.
OMGB.
OsmoLand.
OMG.
OMGB, yeah.
Oh my god.
Yeah, so, yeah, well, we should continue, I think. That was just a comment.
But I think it's just a rough idea we can see when we implement it. And finally, some open questions. They are just, when I wrote all the slides, I thought of problems with them. One thing that I had no idea how to deal with really is you receive, you want to send GSML2 frames that have been transmitted on the channel hopping channels, which means you have 4 RFN values to transmit. You have 4 frame number. It's just annoying because they're consecutive, so you can just transmit the first one without ambiguity.
Are you sure it's always 4 consecutive ones? If you think of SATch or something like that?
Okay, so it's not right consecutive. So yeah, I have no idea how to deal with that in some way. Should we? I mean, that's really something I have.
Could we just repeat the given TLV several times?
Yes, but that's in the solution. Repeat the error block, but then you have to make the API more complex because you have to deal with repeated.
Why more complex? If
you had the function get error.
Which just put the tag ID, so now you need a sequence number.
Also, if we want to use a similar structure than our existing TLV parser, it doesn't really deal with repeated tags. But what we could do is maybe have the same tags, but with 4 times the length of 4 values inside that single tag.
Oh yeah, that's actually
That's maybe a solution. Because then code that doesn't treat it well, it will just read the first value and ignore the remaining 3. And code that is written with that in mind will actually display multiple of such values.
Yeah, I think that's a pretty good way to handle that. Yeah. And then some of the points with they are more like thing to discuss. I think I will rewatch all the comments that have been given here to try to come up with a little more formal specification that take into the various consideration and justification for the decisions. Submit that to the mailing list to get more formal feedback, and then try to specify maybe just GSM, how it fits in there, so that we can see an application of that. And maybe go from there.
Yeah,
that's it.
I think the first thing we should do after the spec is fixed is get the Wiresharks merged as soon as possible, because that will be, it needs some time until it transitions into the distribution and into their builds and so on. So as soon as we get it in there, the easier it will be for people to transition once our applications change.
Yes, because obviously if you start upgrading libosmocore to automatically send GSMTAPv3, and people will most likely update libosmocore more quickly because it moves so fast, and end up with a non-functioning setup. With Wireshark, they might be a little pissed off.
Yeah, now that finally all the stuff is merged, we have to make it incompatible again. Exactly.
That's just iterative development.
Yeah,
that's a
maybe
modern.
we should actually introduce an artificial gap between merging that in Wireshark before we start using it. At least before we start generating.
Yeah,
we
yeah.
already use a new API, but not.
I guess we could like just enable and leave Osmo code that is enable GSMTAPv3.
Yeah, yeah. If we add a new
V3.
API and or we include a translating proxy. Which, by the way, was one of the ideas I had with your embedded source and computation power, is you could always, if you really run into that problem, you could have a proxy that converts your... It's not nice, but it works if it's really a real world problem.
Yeah, and then we could start having things like RTP MOOCs, like GSMTAP MOOCs, GSMTAP proxy, no.
and control it over MGCP?
Yeah. So.
Yeah, a little bit late.
Okay, yeah, it's not a big deal. We have skipped the coffee break now. Anyway, but no, we can still take a coffee break.
Spend 12 minutes to 10.